Welcome to the Turf Zone podcast. This episode features the article, Assessing Application Error on Sports Fields Across Varying Levels of Sprayer Technology and Operator Experience, written by Weston Floyd, CSFM, Megan Muesse, Hailey Tucker, Opeyemi Alabi, Jacob Winger, and Chase Straw, Ph.D., with the Department of Soil and Crop Sciences at Texas A&M University in College Station, Texas, USA. The demand for precise input application and operational efficiency in turfgrass has driven the development of Global Navigation Satellite System, GNSS-equipped sprayers, which offers several advantages over conventional systems. Features like individual nozzle control and automated operation within preset boundaries reduce the need for manual boom control, while enhancements such as sub-centimeter precision correction and autosteer further minimize human error. Despite these benefits, GNSS sprayers have seen limited adoption in the broader turfgrass industry, with increased interest primarily in the golf course sector. Early adopters report benefits such as reduced treated area, shorter application times, less reliance on operator expertise, and improved accuracy. However, testimonials remain scarce in sports field management, where skepticism about the technology's value persists. As the sports field industry increasingly embraces sustainable practices and faces rising labor costs, the demand for technological solutions is expected to grow. Overcoming hesitancy toward new technologies will require extensive demonstrations to promote adoption. Currently, there is limited, unbiased data on the benefits of GNSS-equipped sprayers for sports field managers. This research aims to fill that gap by quantifying application errors on sports fields using different sprayer technologies and operator experience levels. The hypothesis is that as technology advances, discrepancies in misses, overlaps, and overspray will decrease, reducing the total sprayed area and minimizing differences between experienced and inexperienced operators. Study design, equipment, and application process. Research was conducted from winter 2022 to summer 2023 in College Station, Texas, at Veterans Park and Athletic Complex and Southwood Athletic Park. Identical studies were performed on softball, baseball, and soccer fields at both locations. Using a crossover design, 6 treatments, manual GNSS and GNSS plus auto steer sprayer technologies, each operated by both experienced and inexperienced operators, were applied to 3 fields of each type at both locations. Each field received all 6 treatments to evaluate technology performance across operator skill levels. At Veterans Park, a Toro Workman 200 spray system, 18-foot boom, with Ninja GPS spray control, a Smart 7 GNSS receiver, and Polaris auto steer was used. At Southwood Park, a John Deere Pro Gator with an above-par tech sprayer, 20-foot boom, a GPS 7500 GNSS receiver, and Steady Steer auto steer was employed. Both sprayers featured correctional services, individual nozzle control, automatic rate control, on-screen guidance, and adjustable spray parameters. One experienced operator with nearly 20 years of sports field spraying experience, including 3 years with GNSS and auto steer, was assigned to each location. 4 inexperienced college students, new to both spraying and the technology, were assigned to specific locations and field types, ensuring their inexperience remained consistent. Each student received a 30-minute training session on sprayer controls before their first application. Field boundaries were geo-referenced once using the sprayer's GNSS receivers to establish consistent target areas for all fields, aiding in GNSS and GNSS plus auto steer treatments. The average target areas were 74,899 square feet for Veterans Park softball fields and 37,631 square feet for Southwood Park's baseball fields, with soccer fields averaging 88,244 square feet and 33,644 square feet at Veterans and Southwood, respectively. Water was used for treatments at 65 gallons per acre, and designated level areas were marked for filling and draining the sprayers. Sprayers were filled to 150 gallons for Veterans Park and 80 gallons for Southwood, based on field size. At Veterans Park, The dual nozzle sprayer used FastCap 422FC11004 and 422FC1106 nozzles, while South Wood Park used a single nozzle sprayer with COMBOJETSR 11008 nozzles. The accuracy of the water volume in the tank was confirmed by measuring in 5-gallon increments and validating the flow meters against the computer outputs before the initial treatments. Treatment applications occurred from December 2022 to May 2023 at Veterans Park and from June to July 2023 at South Wood Park, depending on field availability and weather. To prevent tire tracks from being used as a guide, sufficient time was allowed between applications for the tracks to disappear. Sprayers operated at 2.5 miles per hour, controlled by a speed regulator. For manual treatments, monitors were covered and foam markers guided operators who manually controlled the booms. GNSS treatments used foam markers and on-screen maps, while GNSS Plus auto steer treatments added auto steer. Both GNSS treatments featured individual nozzle control with a 100% overlap setting. After each treatment, remaining water was drained via valve and hand pump. Spray data were stored in the sprayer's computers and later exported for analysis. Data processing and analysis. The study measured target area misses, overlaps, and overspray. Data downloaded from the sprayer computers included field boundaries, sprayer paths, and coverage. The percentage of target area missed and overlapped was calculated by comparing the spray coverage to the field boundaries, excluding non-target areas. Missed areas were identified where no spray was applied and overlaps where sections were sprayed more than once. These percentages were then calculated as a proportion of the total target area. Overspray was calculated by subtracting the amount of water left in the tank after spraying from the initial volume. The percentage of overspray was determined by dividing the actual volume applied by the intended volume for the target area, then multiplying by 100. Any values over 100% indicated overspray. The percent total volume saved between treatments was determined by subtracting the lower percentage from the higher one, dividing the absolute value of this difference by the higher percentage, and then multiplying by 100 to convert it into a percentage. For example, if treatment A used 105% of the intended volume, that is 5% overspray, and treatment B used 110% of the intended volume, that is 10% overspray, then the total volume savings by using treatment A is 4.6%, calculated as 105 minus 110 divided by 110 times 100 equals 4.6%. Only the 422FC11004 nozzles were used at Veterans Park in manual mode because individual nozzle control could not be turned off when dual nozzles were active, resulting in a lower spray volume since the sprayer isn't designed for single nozzle operation. Therefore, the percent target area overspray was analyzed separately by location as the manual total volume applied data from Veterans Park was unreliable. However, this issue did not affect the percent of the target area missed and overlap, as spatial spray data were recorded for all treatments. Misses, overlaps, and overspray on softball and baseball fields. The results for percent target area missed were similar across locations, so data were combined for treatments and locations. Inexperienced operators using manual sprayers had the highest percentage of missed areas, 3.7%, while experienced operators showed no major differences across sprayer technologies. There was also no difference in missed areas between GNSS and GNSS Plus auto steer, regardless of operator experience. South Wood Park had more missed areas, 2.4%, compared to Veterans Park, 1.4%. For percent target area overlapped, results differed by location, so data are presented separately for each. At Veterans Park, the manual sprayer used by inexperienced operators caused the highest overlap, 8.3%. In other cases, both experienced and inexperienced operators performed similarly across sprayer technologies. As technology advanced, overlap decreased, with GNSS Plus auto steer reducing overlap to less than 2%. At Veterans Park, overspray was similar between operators within each technology level, But advanced technology reduced overspray. GNSS plus autosteer led to 2.1% overspray compared to 6.3% with GNSS, saving 4% of the total water volume. For inexperienced operators, autosteer reduced overspray by 3.3%. At Southwood Park, there were no significant differences in overspray between operators within each technology level, but experienced operators generally had higher overspray. While there wasn't a clear advantage between manual and GNSS or GNSS and GNSS plus autosteer, switching from manual to GNSS plus autosteer significantly reduced overspray. For experienced operators, overspray dropped from 11.5% with manual to 6.5%, and for inexperienced operators, it dropped from 9.7% to 5.7%, resulting in a 3.7% reduction in total water used. Misses, overlaps, and overspray on soccer fields. The results for percent target area missed on soccer fields were consistent across locations, so data were combined for treatment analysis. The manual inexperienced operator had the highest percentage of missed target area, 2.8%, which was higher than all other treatments. There were no differences in missed areas among experienced operators across any level of sprayer technology. Additionally, there was no difference in missed areas between GNSS and GNSS plus autosteer, regardless of operator experience. Similarly, the results for percent target area overlapped were consistent across locations, so data were pooled for analysis. The manual inexperienced operator had the highest overlap, 6.4%, significantly more than the manual experienced operator, 4.3%. The manual experienced operator's overlap was similar to that of the GNSS inexperienced operator, 3.6%, and both operator types showed similar results within the GNSS and GNSS plus autosteer technologies. Overlap decreased as sprayer technology advanced, with both operator types achieving less than 1% overlap using GNSS plus autosteer. The results for percent target area oversprayed differed slightly between locations, so data are presented separately. At Veterans Park, operator experience did not affect overspray with the GNSS sprayer, with both experienced and inexperienced operators having similar overspray rates, 6.2% and 6.5%, respectively. However, the addition of autosteer reduced overspray to 2.3% for experienced operators and 3.8% for inexperienced operators, resulting in total water savings of 3.7% and 2.5% respectively. At Southwood Park, overspray results were similar between operators within each sprayer technology level, though the inexperienced operator consistently had slightly higher overspray. For experienced operators, overspray decreased from 11.1% with manual to 8.3% with GNSS, but there was no further reduction with GNSS plus autosteer, 6.2%. For inexperienced operators, overspray dropped from 12.1% with manual to 10.2% with GNSS, and further to 7.0% with GNSS plus autosteer. Overall, both operator types saw a reduction in overspray as sprayer technology advanced. Moving from manual to GNSS technology reduced overspray by 2.8% for experienced operators and 1.9% for inexperienced operators. Upgrading from GNSS to GNSS plus autosteer reduced overspray by 2.1% for experienced operators and 3.2% for inexperienced operators. Switching from manual to GNSS plus autosteer technology resulted in total water savings of 4.4% for experienced operators and 4.6% for inexperienced operators. Recommendation for sports field managers. Inexperienced operators using manual spray mode had the highest rates of misses and overlaps, except for overlaps on Southwood Park's baseball fields. GNSS and autosteer technologies significantly reduced these errors across all locations and field types. Standard deviations of misses and overlaps decreased with advanced technologies, especially when comparing inexperienced manual mode to GNSS plus autosteer, indicating more consistent applications. Additionally, advanced technology reduced overspray and the total volume applied. Investing in GNSS-equipped sprayers with auto steer minimizes reliance on experienced operators, reduces errors, and enhances consistency. This study used factory settings, so further improvements might be possible by adjusting overlap parameters. Acknowledgements. The authors wish to extend their gratitude to the Texas Turfgrass Research, Education, and Extension Endowment for providing funding for this study. They also want to express their thanks to GLK Turf Solutions and Tracknology for providing the above Partec sprayer and real-time kinematic correction service, respectively, for use in the study. Additionally, appreciation goes to Stephen Richardson, the Parks Operations Manager of the City of College Station, Curtis Richmond, the Southwood Park Supervisor, Keith Fales, the Veterans Park Supervisor, and Ken Rost and Cam Scheifer from Frost Inc. for their support of this project. You have been listening to the Turf Zone podcast. Follow the Turf Zone on X, Facebook, and LinkedIn for all things turfgrass, featuring podcasts, magazines, events, and more. Visit www.theturfzone.com for more.